Okay, looking at the second page of the end of the year test, I'm going to go through the questions on this. Number 8, what is the slope of the line described by the data in the table below? Well, remember, slope is just the change in y over the change in x. So if we look at a change in y here, we can see it goes from 3 to 8. That's a change of plus 5. And then the change in x here goes from negative 1 to positive 1. That is a change of plus 2. So 5 over 2 is going to give us a slope of d, 5/2. On to number 9. Which equation shows the relationship in the table below? Well, remember that you can find an equation. The relationship of an equation is mx, y equals mx plus b. So the two things that we need to find are the slope, the m, and the b, the y-intercept. So the first thing we do is look for the slope, and we're going to find it the same way we did it in the one above. So we're going to look at the change in y over the change in x. So the change in y here, it goes up 6, so plus 6. And then here it goes up 3, so plus 3. That is 6 over 3, or a slope of 2. So now I'm looking for equations that have slopes of 2. That's correct, that's correct. Not that one and not that one. So now what's happening as it's going? Is it adding an extra one after it multiplies by 2? So you can look at that. So now you can just look between, let's change this. So just looking between these numbers. So to go from x to y, is it 5 times 2 plus 1, or is it 5 times 2? So 5 times 2 is 10. 8 times 2 is 16. 9 times 2 is 18. 11 times 2 is 22. So it's just multiplying by 2. All right, so that's our answer. 9 equals A. Let's go back to black. And now let's move on to number 10. Which of the following is the equation of the line graph below? Well, remember again that a line is y equals mx plus b, where m is the slope and b is the y-intercept. So let's look for the y-intercept first. First of all, this line goes through the y-intercept of 0, 3. All right, so it's the y-intercept is 3. The b is equal to 3. So anything that's adding 3 is going to be possible. So it could be A, it could be C, could not be Y, or it could not be B, and it could not be D, because they're adding 5 and 2. All right, so now let's look at the slope. Let's find the slope between some points that we see. So one point is already there for us. Let's look for another point here. Another point I see this line going through is, that's the point of 1, 1. So 1 over and 1 up. All right, so let's see what the slope would be between those 2 points. So let's look at that. So the rise between 1 and 3 is going to be 2. And the run between 0 and, so that's 2, and the run is 1. So the slope is going to be the change in y over the change in x, or the rise over the run. That's 2 over 1. So we're looking for, my bad. The rise is actually negative. It's going down. I'm like, wait a second. I didn't do that right. It's a negative 2. All right, so we're looking for negative 2 over 1. Negative 2. That is going to be answer A. All right, let's look on number 11. Marcus sells homemade pies for $10.50 a pie, and it costs $1.25 for the ingredients to bake each pie. Marcus bought a new oven for $800. About how many, that says about, how many pies must he bake and sell before he recovers the cost of the oven? So what we're saying here is the cost is going to be equal to the sales. So let's look at each of these numbers and figure out, are they part of the cost or are they part of the sales? So Marcus sells homemade pies for $10.50 a pie. That's how much he gets in. So that's sales. So we're thinking $10.50 times each pie that he sells. Let's just call that X, where X is equal to the number of pies. Okay. So all the sales that he makes comes from the $10.50 times X. Now the cost, he's got two costs going out. He's got the ingredients cost per pie, and he's got this $800 cost. All right, so we can set that up as two different costs. The first one is $1.25 times X, or the number of pies, plus $800. All right, so now all we have to do is solve for X to find the number of pies. Let's just subtract $1.25x from both sides. That's going to give us 25x here. 9.25x is equal to 800. All right, so now all we need to do is divide by 9.25 on both sides. All right, so if you use your calculator for that, you can find out that that gives us x is left over here. And on this side, we have 86. I don't know if you can see that. 86.5. Can you have half a pie? Can you sell half a pie? Not really. Okay, so we'd have to round up for that. So let's say that x is approximately 87. So our answer would be C. All right, moving on to number 12. Which of the following graphs shows a linear relationship? I think this is pretty clear. They're looking for a line. Our answer is A. Number 13. What is the value of n in the equation 8n plus 9 equals negative n plus 5? We're just solving for n. It's very simple, but I'll go through the process with you. 8n plus 9 equals negative n plus 5. All right, I'm going to add 1n to both sides, and I'm going to subtract 9 from both sides. So I'm moving my unknown, moving my n to the left side. I'm moving my constants, just my numbers, to the right side. All right, so getting rid of that and getting rid of that, that means I'm going to have 9n equals, now 5 minus 9 is negative 4. All right, so 9n equals negative 4. Now I've got to get rid of this 9 that's been multiplied by n by dividing by 9. Whatever I do to one side, I do to the other. That's going to give me n left over here, and that's equal to negative 4/9. So our answer is B. Number 14. Which of the following equations represents a proportional relationship? Well, remember, for proportional relationships, we're looking for a line that passes through the origin, right? So it has to be a linear equation. It has to pass through the origin. What does that mean, to pass through the origin? It means that it's not going to have anything added or subtracted from it. It's not going to have that that b that we think of. Remember, the y equals mx plus b. There's not going to be any b, because that's going to be 0, right? B equals 0, or the y-intercept equals 0 when it passes through the origin. Okay, so let's look at that. First of all, I see these things are not going to fly, all right? We can't have those. Those are the b, right? If a value for b that's not 0. But now look at what we've got left. Are both of these linear equations? Well, no. A is a linear equation and C is not. You can't take a number and divide it by x, by the variable, and keep that as a linear equation. That's not going to be linear, so our answer is A. All right, let's look at our last one, 15. Which of the following tables represents a function? Remember, our functions have one output for each input. Remember, it's kind of like when you go to get some candy out of a machine and you press a button. You want to get the same thing every time. Now, you might be able to press multiple buttons to get Cheetos or whatever it is you want to get, okay, from your vending machine. But you don't want to press A6 one time and get Cheetos and press A6 one time and get Funyuns, because I like Cheetos, but I do not like Funyuns. Okay, so what are we looking for? Well, we're looking for multiple values, or we're looking for x that has the same value but has different partnered y's, if you will. We were looking for different outputs for the same x. And if you look at A, you can see that right here. So here's the same number for x, but they've got two different outputs, two different y's. Nah, can't have that. All right, looking at B, it does not look like we've got any different x's, so that would be good. We're thinking about using B. Let's go on to C and see if we see anything here. Well, we've got the same x's and different y's, so that won't work. Looking at D, oh, we've got the same x's but different y's, and that won't work. So our answer is definitely B.